Okay, so the first thing we're going to have is just an x plus 2y is equal to 4. And then we're going to have y is equal to 2x squared. Okay, so first of all, we know this is a linear equation y because it has no power. There are no powers to it, okay? So we want to eventually change this to y equals mx plus b, okay? And so we know that this is a quadratic, okay? Now, when we say quadratic, we can think of a parabola. We're going to think circles. We can even think ellipses, or even hyperbolas. Okay. I think what I'm going to do from what I learned yesterday is kind of break this down now. Quick and easy. How do I know that this is a parabola? Only one variable is squared. What's that? I'm just going to break it down so you can see it. Yep. So how do you know it's a parabola? Well, you know that's going to be only one variable is going to be squared. It could be the x, which means that the parabola opens which way? Up or down. And if the x is squared, sideways. Okay, good. So now circles, we're going to have something like x squared plus y squared is equal to r squared, right? That's if we know that it's centered at the all right, so then we have got a parabola, we've got the circles, and then we have our ellipses. And our ellipses, if you remember, we've got like x minus h squared over a plus y minus k squared over b is equal to 1. Okay, so basically what we're looking for is we're looking for a fraction. It's a plus and it equals 1. Okay, and then your hyperbolas are going to be just like the ellipses, except that it's a minus, but it's still equal to 1. Okay, so going from the review, our first two equations, we want to change this one into slope-intercept. So I'm going to come down here. How much work do you guys want me to show? All of it. So I'm going to subtract my x. So it looks something like this. So I have 2y is equal to negative x plus 4. Okay. And then I'm going to divide by 2 to each term. Okay. Now, the biggest mistake is that somebody will just draw a big line here and hit divide by 2, and they'll forget to divide the x by 2, right? So if you break it up like this, then you're going to remember that each term is going to be divided by 2, okay? So then you're going to have y is equal to negative 1/2 x plus 2, okay? So what is my slope? Okay, perfect. And then what is my b? And what does that represent? Y-intercept, so I can write it as 0, 2, correct? Okay. So then what kind of quadratic is this one? Is it a parabola, circle, ellipse, or a hyperbola? It's a parabola. How do we know it's a parabola? Only one variable is squared. Okay, so I'm going to pause it for just a second because I'm going to draw a coordinate plane 10 by 10 by 10, okay? Meaning it's going to be 10 units on each of the axes. So here is our 10 by 10 coordinate plane. we're going to graph the linear equation first. So I know that at 0, 2, so I'm going to put a point here at 0, 2, that's where my point, my y-intercept's going to be, okay? My slope was negative 1 over 2, okay? So I'm going to go down 1 and right 2. I can also go up 1, left 2, all right? Once I've got those 3 points, I'm going to connect them. All right, now for my coordinate, for my quadrant, not my quadrant, how about my quadratic? All right. We'll put it here so I don't have to make you guys motion 6. I'm just going to make kind of a T-chart, okay? And why do I know this is 0, 0? That is the origin. I think it's vertex is what you're looking for. Yeah, the vertex, because if I put 0 in, everything goes to 0, that means that y. So I know I'm going to be at 0, 0. I personally think the easiest way to graph this is just to put in numbers real quick. So if I put like negative 1 squared, what's negative 1 squared? You would say 1. 1 times 2 is, so then what's this one got to be right here as well? Because the distance is the same, so we know it's symmetrics, okay? So what's 2 squared? 4, thank you, and that's also 8. So now I have 5 points, so I'm going to go 1, 2, and then I'm going to go 2, 8, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2. And then I think the hardest part of the whole thing is drawing that parabola. Now, the thing I don't like about the graphing is, yes, I can see that I intersect at those 2 points right there. And now I have to estimate exactly what that is, all right? So I'd come up to here and say, well, I know that it's going to be like, say, 1, comma, that's a 1, that's a 2. So I'm just going to go 1.5, okay? I know I'm at negative 1, and then it's a little bit above 2, so 2.5. And because we're on Wednesday when I do the class lecture, we're going to talk about how to solve those algebraically, okay? So right now during the graphing phase, you can only just really estimate where exactly we're at, okay? And that's, I think it's a little bit frustrating, okay? Okay, so what should I do first with this linear equation? It needs to look like what, guys? Perfect. So I need to get y by itself, correct? Let's subtract the 3x. My algebra good? Okay. So now, well, let's come over here and do this one real quick. So I'm going to go x is equal to y plus 1 squared is equal to, oh, not equal to, how about plus 2, right? Because all I did was just go plus 2, right? Okay. So what kind of quadratic is this one? It is a parabola. Which way is it going to open up? Sideways. How do we know it's sideways? Perfect. Okay. How about this? What's my vertex? 2, negative 1. Because remember, open sideways, you got to do the opposite. So that's 2 is your h. That's your k. So negative 1. All right. Let's. All right. Where should I put my numbers that I want to solve for? Do I want to put them in the x or do I want to put them in the y? I got to put them in the y. Okay, why do I want to put them in the y? Exactly, it's my input, so that's where I'm looking at. So that's what I'm wanting to find out what x is. Because if I put the x in, you then have to subtract 2, you have to take the square root, and then you have to take the plus or minus 1. Or sorry, you'd have to minus 1. So it's doable, it's just a little bit more work, right? Right. Okay. So if I put 0 in for y, what's 0 plus 1? 1. What's 1 squared? So then what is 1 plus 2? 3. Okay. So I just want to show you something. What's negative 2 plus 1? Well, negative 1, right? And then negative 1 squared is, what's 1 plus 2? So you can see, remember that axis is symmetry? So as long as this distance is the same, you only really have to do the problem once. Okay, does that make sense? That's why finding that vertex is so important, because then it helps reduce your workload. Okay, so if I put 1 in, what's 1 plus 1? 2. 2 plus 2. Sorry. So 1 plus 1 is 2. 2 squared is 4. 4 plus 2 is, there I go. I got my math right that time. Whew, that was a struggle. Okay. So real quick, just so we're not drawing a bunch of graphs, what quadrants is this going to be in? So if you guys remember, it goes 1, 2, 3, and 4, right? Yeah, it goes backwards. I know. So this is plus plus, right? This is minus plus. This is minus minus, and this is plus minus, because the x is plus. Okay. So if I look here, that's quadrant 4, quadrant 4, quadrant 4, quadrant 1, quadrant 1, right? Okay, so I'm going to try and just graph it in the first and second quadrant, okay? Okay, so first thing I'm gonna do, I'm gonna graph my linear line. I know at the negative 9, it's a positive slope, so I'm gonna go up 3, 1, 2, 3, right 1, right 1, and then I'm just going to connect those 3 points. Okay, and I'm going to come to my vertex. I'm at 2, 1, negative 1. So right there, I'm at 3, negative 2. I'm at 3, 0. And then I'm at 6, 3, 4, 5, 6, 1. And then 6, negative 3. So then I'm going to estimate it. You know what? Just to make life easier, I'm going to say it cuts it at 3, 0. I'm going to go right there. So I'm going to say 2. So negative, sorry, not negative, 2.5. And right here, so negative 1.5. What's that? Yeah, because it's a total estimate of what you've drawn. Okay. And no offense to you, sir, but you're kind of messy. So I give you a little bit wider berth at getting stuff in. Okay. Some of you are very clean and organized, and it's easy to see, but some of us are a little bit more messy. Okay.